Here we shall solve a few examples on regression line, regression curve and conditional expectations and all. Okay, so these examples are very important, okay, for exam. So the first one, two random variables x and y having least square regression lines, as 3x plus 2y minus 26 equals to 0 and 6x plus y minus 31 equals to 0. Then find expectation of x, expectation of y and row x comma y. Okay, the regression lines are given by this and this. We need to find out these three. Okay, now here we need to use one formula, that is the regression lines intersects at the mean point. Okay, regression lines intersect at the mean point. Mean point means mx and my. That means by solving these two, whatever value you get, one for x, another one for y, that value will be the mean of x and that value will be the mean of y. So if you solve these two two linear equations, you can easily solve it. You will get the value of x is 4, which is the mean of random variable capital X and the mean of capital Y, which will be 7. Okay, now two regression lines are given. Let's take the first one is y on x and the second one is x on y. Okay, so let the first one, which is 3x plus 2y minus 26 equals to 0, is the regression line of y on x. Okay, so try to find its slope. So we are writing it in that form, 2y equals to minus 3x plus 26, that is y equals to minus 3 by 2x plus 13. Right? So minus 3 by 2, this quantity becomes the slope of that regression line. Now we know what is the slope of the regression line. This is denoted by byx and it takes the value rho sigma y by sigma x for y on x, regression line of y on x. So this value must be minus 3 by 2. Right? Now take the next equation, which was 6x plus y minus 31 equals to 0 as the regression line of x on y. Okay, we are taking it arbitrarily. You can take in reverse order also. That is, the first one is for the x on y and the second one is for the y on x, the same thing. Okay, so now putting it in that form, try to get the mean slope of that line, then you will get, if it will give you x equals to minus 1 by 6 into y minus 31. So this quantity must be rho into, according to the formula, which is bxy, which is equal to rho into sigma x by sigma y, which is equals to minus 1 by 6. Okay, now take this thing and that thing together. So find their product. Sigma x sigma y got cancelled out. You get rho square equals to 1 by 4. So rho equals to plus minus half. Okay, now if you take rho equals to plus half, put it over here. Okay, so half into sigma x by sigma y equals to minus 1 by 6. But we know sigma x is standard deviation, it is always positive, and sigma y is also always positive, but it becomes negative. To putting 2 on that side, you will get minus 1 by 3, which is not possible. So rho cannot be plus half, that is rho must be equals to minus half. Okay, so we have calculated expectation of x, expectation of y and rho xy. Okay, this type of examples are very important for exam. Next one, the probability density function of two independent random variables x and y are given as f1x, this is equals to 4ax for 0 less or equal to x less or equals to r and 0 elsewhere, and f2x which is 4by for 0 less or equal to y less or equal to s and 0 elsewhere. Okay, f1x and f2x are two probability density functions of two single variables capital X and y, and they are independent random variable. It is given. Now find out rho of x plus y comma x minus y. Okay, so at first find out the individual expectations, that is expectation of x. It's very easy because the individual probability density function is given. So expectation of x will be, it is continuous, so integration minus infinity to infinity x fx dx, right? If so here that range is 0 to r, x into fx is our actually f1x, so 4ax dx, just integrate it, you will get the value as 4a r square by 3. So this is our mx or expectation of x. Similarly you can find expectation of y which is my. Okay, now take this one as some u and this one as some v. So let's u equals x plus y and v equals x minus y. We have to find out rho of u comma v. So it has the value covariance of u comma v by sigma u into sigma v, right? So let's try to find out covariance of u comma v. So it has the formula that covariance of u means x plus y and v means x minus y. So covariance of x comma y was expectation of x minus mx into y minus my. So that will be expectation of first variable minus its expectation which is mx plus my into second variable minus its expectation which is mx minus my, right? That means expectation of, in first bracket, x minus mx plus y minus my into x minus mx minus y minus my, right? That means we can write it expectation of x minus mx its whole square, a plus b into a minus b, so a square minus b square. Again we can split that, so expectation of x minus mx its whole square minus expectation of y minus my its whole square. Now check, this is actually the variance of x, so var x minus variance of y. Now variance of x means sigma x square and variance of y means sigma y its whole square. So now our next target is to find the variance value or the sigma x square its value. Now to find the variance we need to use that formula. Variance of x is expectation of x square minus expectation of x its whole square. Now you know how to find out expectation of x square. This is minus infinity to infinity x square fx dx, and this is our mean, so mx its whole square. Calculate that value, we already calculated it, put it and get the value of variance of x. Similarly calculate the value of variance of y, so you get the value of covariance of x comma covariance of u comma v. Okay, now next topic is you need to find out sigma u. That means sigma squared u gives you variance of u, right? That means variance of x plus y. That will give you variance of x plus variance of y. We already calculated it, put it. Similarly, variance of v will be variance of x minus y. The value is variance of x minus variance of y. Put the values and then calculate rho of u comma v. Okay. Next example. For the continuous distribution defined by fxy equals to 3x square minus 8xy plus 6y square, where 0 less than x less than 1 and 0 less than y less than 1. Find the regression curves and the regression lines. Very simple question. We know all the formula. We just need to calculate it one by one and put it in the formula. I am giving the hint. Regression line and the regression curves. So first you want to compute the regression curves. So let's find out the regression curve of y on x. That formula is y equals to myx, right? Now myx means expectation of y when x equals to x is already happened. So it has the formula minus infinity to infinity y fxy dy divided by fxx, right? Now fxy is already given in the question, so you can find the denominator. To calculate the numerator, we need to use its formula. So fxx means the marginal distribution of x, which has the formula minus infinity to infinity fx comma y dy, right? Put it, integrate it, and you'll get the value. Put it over here, you will get the first regression curve, that is regression curve of y on x. Similarly, you can calculate the regression curve of x and y. Okay. Now the next topic is how to find the regression line. So for calculating the regression line, what we need? So regression line of y on x is y minus my into rho sigma y by sigma x into x minus mx, right? So to calculate the regression line, first we need to compute my, that is expectation of y. You know how to do that. Then expectation of x. Then you need to calculate variance or the standard deviation of x, standard deviation of y. Then we need to calculate the value of rho. Rho takes the formula covariance by sigma x into sigma y. So just put the formula one by one, you will get the result. Okay. It is a little bit calculation type, lengthy, but the simpler one. Okay. This type of examples are very important for exam. Don't skip it. Next. Another example which is also very important. The joint probability density function of two random variables x and y is given by excuse me, f of x comma y equals to k into 1 minus x minus y, where x greater or equals to 0, y greater or equals to 0, and x plus y less or equals to 1, where k is a constant. The joint probability density function of two random variables x and y is given by this. Then number 1, find the mean of y when x equals to half, and find the covariance of x comma y. Okay, so first we need to get the value of k because k is unknown here. Let's draw the region. This is the region x greater or equal to 0, that means this quantity, and y also greater or equal to 0, that means this quadrant. Now another straight line is there which is x plus y less or equal to 1, so this one, that means this is the required region. Point is 1, right? Now get the value of k. To get the value of k, we are using that formula, that is, if you integrate the probability density function in the whole range, it will give you the value 1 by its property. So by using this integration, you can easily get the value of k. We have already solved this example in previous class of second order random variable. Okay, so k will give you 6. Okay, then we need to find out the mean of y when x equals to half, that is expectation of y at the point x equals to half, that is my half. It has the formula minus infinity to infinity expectation of y by fxx. You know how to calculate all of this. Put the value of fxx, we just did it for the last one, minus infinity to infinity f of x comma y dy, right? Calculate all of this, you will get the result. Similarly calculate covariance. All the examples are calculation based, okay, not that tough. Next example, the random variables x and y are connected by the linear equations, by the linear relation 2x plus 3y plus 4 equals to 0. Then show that rho of x comma y equals to 1. Okay, sorry, minus 1. Rho of x comma y equals to minus 1. Only the one thing about x and y is given as this one. They are related by this 2x plus 3y plus 4 equals to 0. So we are starting with this line. Taking expectation on both sides. That is 2 expectation of x, that is mx, plus 3 my plus 4 equals to 0, right? Now take this equation and this equation and subtract them. So if you subtract these two, what will you get? 2 into x minus mx plus 3 into y minus my equals to 0, right? So 2 into x minus mx equals to minus 3 into y minus my. Take square on both sides. 4 x minus mx its whole square equals to 9 y minus my its whole square. Now take expectation on both sides. We can put the constant outside. So 4 expectation of x minus mx its whole square equals to 9 expectation of y minus my its whole square. Now check what is expectation of x minus mx its whole square. This is our variance. So we can write 4 into variance of x. Variance of x means sigma x its whole square. So 4 sigma x square equals to 9 sigma y square, right? Now taking square root on both sides, 2 sigma x equals to 3 sigma y. So we got this relation. We are not considering the negations because we know standard deviations are always positive. Now try to calculate rho. What we need to find. Now rho means covariance of x comma y by sigma x sigma y. Covariance means expectation of x minus mx into y minus my by sigma x sigma y. Okay. Now put the value of x minus mx or y minus my by using the other one from the previous relations. So we are getting expectations of minus I guess 2 by 3 x minus mx its whole square just by putting its value by sigma x and putting the sigma y's value, that was 2 by 3 sigma x. Okay, so put that minus 2 by 3 outside, you are getting expectation of x minus mx its whole square. Again this is variance of x, so we can write sigma x its square by 2 by 3 sigma x its square, got cancel out, you are getting minus 1. Next one. 2 points are independently chosen at random. 2 points are independently chosen at random on two sides of a square. On two sides of a square. The length of the sides are A, B. Okay. Then find the mean area of the triangle. Then find the mean area of the triangle formed by the line joining the two random points and the sides of the square. Joining the two random points and the sides of the square. So let's draw a square. Okay, the length of the side being B, not A, only B. Length of the side being only B. Okay, that means it's a square, so it must be same for both the sides, B and B. Now 2 points are chosen at random. Suppose I am choosing here first one P and here first one Q. They are chosen at random. That means by choosing this length, suppose this point is A, so AP if denoted by the random variable capital X and AQ is denoted by the random variable capital Y, they must be two uniform random variable because the points are chosen at random. Now we know what is the uniform distributions probability density function. That is fxx will be 1 by b minus a, that is 1 by maximum value minus minimum value. So maximum value could be b, minimum value could be 0. We can choose the point here, 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 up to here. So maximum could be b, minimum could be 0. So 1 by b minus 0 for 0 less or equal to x less or equal to b. Similarly for y also, fyy is 1 by b minus 0 for 0 less or equal to y less or equals to b. Now we need to find out the mean area of the triangle APB. So APB, this triangle's area's mean. Mean area, that means the mean of the area, that is the expectation of the area. So what is the area of the triangle? Half of AP into AQ. Now AP is denoted by capital X, AQ is denoted by capital Y. So half of XY, we need to find out its mean or its expectation. So expectation of half of XY. Formula is very simple. Minus infinity to infinity, minus infinity to infinity, half XY, fxy, dx, dy. Right? Now we don't know this fxy. This is the joint probability density function, but we do know the marginal density functions. Now check, capital X and Y are two random variables. They are independently chosen. 2 points are independently chosen at random. That line is given in the question. That is, 2 points are independently chosen. So both the random variables capital X and capital Y are independent of each other. So instead of fxy, what we can write? We can write fxx into fyy. Okay. Now you know all the values. Put it and integrate. You will get the result. Next one. If x1, x2, xn are mutually independent, normal, 0 sigma variate, normal 0 sigma variate, then show that variance of x1 square plus x2 square plus xn square by n, this is equals to 2 sigma to the power 4 by n. Okay. Now independent, okay, normal 0 sigma variate. In general we know that normal m sigma variate we know about. Okay, but here it is 0 sigma variate. That means m equals to 0. That is m of that normal random variable, it has two parameters m and sigma. M is equals to 0. Now we know for a normal variate expectation is m, right, which is given as 0 here. Okay, now all are same, x1, x2, xn, all are normal variate, normal 0 sigma variate. That means their expectations are also same, their variances are also same. So expectation of xi, that is x1, x2, xn, all are same, which is equals to m, and which is given in is 0. And variance of xi, they are also same. So let's take this is equals to sigma square. We can take sigma 1 square, sigma 2 square, sigma n square, but as both are all are same, so we are taking it as sigma square. Now variance of xi has the formula expectation of xi square minus expectation of xi its whole square. Put the value, that means expectation of xi square minus this value is 0, so 0. So from here we are getting sigma square equals to expectation of xi square. Okay. Now it is given all the xi's are independent. So starting with variance of x1 square plus x2 square plus xn square by n. Okay, we need to find this value. Now you know one formula, that is variance of ax plus b equals to a square variance of x. So we are using it over here. We can write it 1 by n square variance of x1 square plus variance of x2 square plus variance of xn square, right? So take one, try to find out 1 by 1 each. So variance of xi square, it takes the formula, when variance of xi was there, formula was expectation of xi square. So when it is square, we need to use this square also, that is xi to the power 4 minus expectation of xi square its whole square, right? Now we know this value is equals to sigma square, we have already taken it. So sigma square its square, and to calculate this value we can apply the mu function, which is the mu means how to calculate the moment with respect to the origin. So apply it, you will get the result as 3 sigma to the power 4. So 3 sigma to the power 4 minus sigma to the power 4, that is 2 sigma to the power 4, right? So put it over here, this occurs n times, that is the answer is 1 by n square into n times 2 sigma to the power 4, that is cancel out n 2 sigma to the power 4 by n. Okay, this proves the example. Now whatever example I did in that class, all are important for exam, very much important for exam, so don't skip any of this. Okay.